Yes, thanks everyone for joining our bi-weekly live peer community call. We host these once every 2 weeks, and they're open to all to participate in the Google Hangout or to watch and follow along on crypto.livepeer.tv. Right now, we think the stream is being recorded. We're troubleshooting the live stream, but we'll try and get that up and running as well. Nelson, who has done a great job kind of as a community lead coordinating these calls, has a great agenda for us today, focused on Streamflow. So I will kick it over to Nelson to take it from here.
Thanks for that, Doug. Yeah, so as Doug briefly mentioned, today we're going to have more of an update call, running through a few different topics, including Streamflow progress, GPU transcoding, the video developer productization and pilot program, and we may briefly touch on the new token holder experience. To start off, we're going to run through a general update from the team on progress in regards to Streamflow. And the first point we wanted to run through was progress on GPU transcoding specifically. So I'll pass over to you, Doug, to talk through, or is it Yundin?
Sure thing. Yeah, I can give a quick update on GPU transcoding, and then I invite some others from the team to add some color around specific areas. So, as you know, one of the big promises of LivePeer, one of the big opportunities is that people who are currently mining cryptocurrencies with GPUs, currencies like Ethereum, Zcash, Monero, etc., have these idle chips on those GPUs that can only encode and decode video. They can't hash cryptocurrency. And so one of the promises of the LivePeer software and LivePeer network is that if video gets routed to these mining GPUs, they can put those chips to use to encode the videos, and they don't have to disrupt their cryptocurrency mining very much. They have kind of minimal efficiency loss there. And so this is really powerful because it means that these millions of GPUs spread all around the world could be used in a really cost-effective manner to do video encoding at scale at dramatically lower prices than what a lot of the kind of cloud providers are charging. And also for all of these miners, it creates additional revenue that's far more lucrative than the mining opportunities that they're pursuing without any opportunity cost, because they already have these chips deployed, they already have them spread around the world, and they have components on there that are available to encode video doing nothing. And so we're doing a lot of work to enable this GPU transcoding in Streamflow, and we made a lot of progress. And the kind of steps that we've taken were, we kind of have gone step by step trying to unlock this opportunity. So the first thing that we did was just say, okay, forget mining, let's enable the LivePeer software to leverage these GPUs for encoding. And so we did a lot of work to add support for the NVIDIA GPU cards, which are kind of the most popular commercially sold cards out there, and got the GPU transcoding working and ran a bunch of tests and benchmarks. We ran them ourselves in our office with actual hardware. We ran them with GPUs in the cloud, in Google and Amazon, and we've run them inside of mining data centers with a number of partners as well to get video transcoding working. So good. The LivePeer is now GPU enabled for transcoding. Step one. Step two was, can we run this transcoding at the same time as we're hashing cryptocurrency? And we, again, took an iterative step where we did some crude tests where we just, running ETH miner processes and mining crypto and routed video into them, and saw that it would work in some scenarios, and in other scenarios we saw, oh man, like the process just died and the card froze up. What's going on there? And so we did a lot of work to debug and figure out, what sort of mining algorithms is this working well on, what is it not working out well on, how do you tune the memory and the compute parameters in order to handle the kind of simultaneous encoding here. And the result of that is that we now have a bunch of benchmarks that show kind of how how much it shows the effects basically of transcoding video in real time, transcoding as much video as possible while simultaneously mining. And we've kind of upgraded our software to support that and fix a number of bugs along the way as well. And so I might kick it over. I don't know if these benchmarks are in a presentable way. Maybe Eric or if Michael's on the call, they could share a little bit. But some of the highlights are that to encode video in real time, so a live video, if you have like one live video stream coming in, it disrupts the mining very, very little, like less than a couple % mining efficiency to encode one video in real time. And good news is, what people pay to encode one video in real time is so much higher than what you're earning through the mining anyway, that losing 1 to 2% of your mining revenue while video is encoding is a no-brainer. It's no problem. If you do another test where you send as much video as possible and try and saturate all the capacity on the chip, you lose a little more efficiency than that. You can share the numbers maybe in the 10 to 20% range. But again, now you're talking about either doing like really high quality encoding that's really compute intensive and expensive, or encoding many, many videos at the same time, which again is like more revenue relative to the mining. So these are like really positive results that we're super excited about. We have instructions published on GitHub. There's a repo called Bot Miner Setup that walks through anyone who wants to configure this side by side. And it's still very technical. It's installing drivers for your cards, doing some custom configuration. But the end result of this is you can run an ETH miner process, and you can run live peer side by side, and you can validate that this works. And this will be the instructions people follow on the Streamflow testnet as they're testing this and getting set up to run this in production. So I think that's kind of the high level summary. Eric, do you want to maybe add anything or more about the benchmarks or the early results that we're seeing, with the caveat being they're all early?
Yeah. I mean, I think you gave a great overview. The only thing that I want to put out there is that this is our very first benchmarking, right? And all the stuff that we've done is from like a pretty naive setup. We were running 2 processes side by side, right? Like really just only relying on the NVIDIA driver to do all the coordination of the work, giving it absolutely no hints on what to do. And also we've only run this on Ubuntu. So in other, like on other OSs, it might be different. And part of the reasons of running this benchmark is to kind of set some expectations to the community around like what we have discovered, but also since the LivePeer is an open network, I think a lot of it is going to be up to the communities to kind of run it themselves and get their own benchmark and work together with the core team to improve the software and the efficiency over time.
And one quick question. So, I mean, I'll be honest, I don't know a lot about Ethereum mining, but I imagine a lot of the miners are using mining pools or sort of specific mining software. I guess the next step from here is once this is all live, community members could work to integrate LivePeer transcoding to some of these sort of mining pools and software solutions, right?
Yeah, for sure. There's a lot of possibilities around that. All the software is open source and pretty modular. So I think we're also like not like, while we understand kind of how mining works, we're not like miners ourselves. And I think there's gonna like, we're looking forward to learn a lot from the mining community to figure out what kind of software is best used to run this. So for example, one of the big questions that we currently have is kind of on the orchestration of the software, right? So if you are a scaled miner, or if you have a lot of GPUs and you belong to a mining pool, like what's the preferred way for you to deploy software to all the machines in a scalable way? Like, how do you monitor them? Like, is there some kind of open infrastructure that we should modify our software to plug into to make it easier for the miners to use?
Okay, very cool.
Yeah, we're in the process of looking for feedback, and we'll publish a post with some of this information either this week or next week, so that people can kind of have some information to follow up on this.
Yeah, one thing to hide about kind of the new architecture of how you run infrastructure in Streamflow is that, you know, the orchestrator nodes, which look a lot like the transcoder nodes of today, they're kind of the smart, aware, live peer aware nodes that are responsible for kind of doing the transcoding work and staking to secure that transcoding work, but they're outsourcing the actual work to these transcoder processes, which may be running on these GPUs that are concurrently mining. And one thing we learned is there's many, many different types of GPUs that have kind of different capacities for doing this transcoding. Some can support 10 concurrent streams at once because they're really powerful, and some kind of peter out after 1 or 2 streams, or may even fail or not keep up with real time. And the kind of architecture in Streamflow is that these kind of transcoder processes are expected to be done. They're expected to fail. And what the orchestrator does is it may use multiple of these transcoders in order to get the work done. It may fail over and try another transcoder if one doesn't return the result quick enough. And so hopefully the software that we put out there, although it can certainly be customized and improved by miners for their specific setups, it should create a really reliable network where people can plug any of this GPU hardware in as transcoders kind of behind the orchestrator process that they're running.
Okay, so that's all the questions I had specifically on GPU transcoding. I guess one other question that just came to mind is if anyone on the call is currently an Ethereum miner or would like to get involved and learn more about this, where can they go?
I think the first stop would be the transcoding channel in our Discord. And from there, we can kind of have more in-depth conversation.
Yeah, we've been pointing people who do show up there to this miner setup repository on GitHub, which has kind of like instructions for getting started. Have we gotten any feedback through that channel yet, or have we heard anything? What should we encourage people to do? Just engage in the Discord, to file issues, to post in the forum? Michael, what do you think?
I think actually participating on the Discord would be the best way to go right now. There hasn't really been any feedback other than internal testing. So I have to assume that means either people used it and it's working perfectly, or maybe they haven't used it. I think chances are it's only really been tested internally, but it's available for anybody to test, and we welcome you to do so.
Okay, terrific. And okay, so the next topic I wanted to move into was talking a little bit about probabilistic micropayments. So I'm not sure if everyone saw the update the LivePit team put out this week, running through a few of these topics. But I thought it'd be great to talk a little bit about how probabilistic micropayments are progressing, and yeah, what progress you guys have made there.
Yeah, so I can talk a little bit about that in terms of progress. What we have implemented over the course of the past couple months is smart contract code for what we call like the ticket broker, which is essentially a contract that would live on Ethereum and would manage your deposited funds for someone that wishes to pay using this PM system. And it also implements validation logic for the actual tickets themselves. So in this system, each payment is actually a lottery ticket that has a specific expected value that it can be derived from its face value and a winning probability that it's configured with. And the face value is like the lump sum payment that you actually receive and that will be settled on chain if you receive a winning lottery ticket. And if you don't receive a winning lottery ticket, then you don't need to redeem it on chain. But the idea is that each lottery ticket ends up representing a specific expected value. So if you are dealing with a very high volume use case where data processing, streaming data processing is one example, and in a live transcoding context, that's one example of streaming data processing. So if you're dealing with a high volume use case, you'll find that over the course of many, many transcodes over many, many small segments, because you're receiving such a high volume of lottery tickets over a period of time, you're going to be paid the expected amount fairly. So if you're receiving a $10 lottery ticket and the winning probability is such that the expected value of each ticket is 1 cent, you'll know that over the course of a specific length of time of data processing that you'll receive that $10 fairly. So that's like a basic overview of the system, and the ticket broker contract handles the validation for those tickets as well as the funds, escrowing of the funds. And what we've also implemented is a Golang package, which serves as a client implementation for both sending and receiving these tickets. And right now it's integrated with our live peer node, such that the live peer node can use this package and create tickets that can be sent to a recipient, and the recipient uses that package to validate those tickets locally. And if it's ever the case that it receives a winning ticket, it can redeem them on-chain with the deployed smart contract. So we've made good progress on both sides. So we have the contract implementation and we have the client implementation. And right now, the plan for the next period of time through the external test network deployment and through the mainnet release is a few things. We're preparing for a security audit, which is going to include a few other contract changes as well. But one big component is auditing the smart contract that we've written for processing tickets on chain. And we're in the process of preparing for that and kicking that off soon. And then after that, there will be some more like optimizations and cleanup work to be done for the client implementation. So that's kind of what we have going on for probabilistic micropayments, specifically in the next chunk of time.
Yeah, I would add a few things. So one is, we have the internal Streamflow test running, and one of the big things being tested and validated is that these probabilistic micropayments are working. And they are. And one of the cool things that Jan and Nico have built is this mechanism that kind of changes the gas prices on Ethereum. So they change the cost for what it means to do a transaction on Ethereum. And what we can observe is that the workers on the live peer network, the people running the orchestrators, transcoders, the software automatically updates the parameters for these tickets so that regardless of how the gas price changes, they don't have to pay a higher percentage of their earnings to cash in these tickets. So you can think of it almost like a credit card where the merchant always pays a 3% fee to Visa or MasterCard in order to accept a credit card payment. In probabilistic micropayments, you can determine whatever fee you want to pay. You can say, I want 1% fee being paid to Ethereum to cash these payments in on the blockchain, and you can set the parameters of your tickets correctly so that you never have to pay more than 1%, regardless of where the gas prices go. So if the gas price is really low, like 1 GUA, well, no problem, you don't have to pay that much. But if the gas prices go up to 100 GUA, it's still theoretically possible for you to be able to cash these tickets and not pay more than 1% of your earnings to do so. And there's some consequences, like you'll get paid more infrequently, but you'll still earn exactly the amount of work that you did. And that's also, validated and working well. So that's kind of the point of Streamflow, is that it'll scale even if Ethereum gets congested, and it won't block usage on the network. And that's so far working well internally. Oh, the other point is at DevCon, the Ethereum Developers Conference, in a week and a half, Yanin and I are giving a presentation on probabilistic micropayments for those who are kind of technically inclined to learn about the security and the trade-offs and comparisons to state or payment channels. So if anyone is attending DevCon, come to our talk Thursday morning, 9 a.m. I think. We'll see. We'll see if that gets locked in.
Okay, very cool. And so now the testnet. So I saw in the piece saying the testnet will be live on the testnet first week of October. Is that right? So you achieved 99.99% reliability on the testnet. What are the next steps now to sort of achieve that reliability on the mainnet?
So I think that the point in the post was, okay, so we've achieved 99.99% reliability internally on a test net, which is a little easier because we are running all the infrastructure. We know how to run it, and it's in kind of a high availability environment, right? And so what we want to do on a public test net, where anyone can join and run orchestrators, transcoders, we want to show that even if they're running them unreliably, the end result is that we still get this really high 99.99% reliability for video transcoding jobs for users on a public test net. So that's going to be kind of the main goal or objective that allows us to then say, okay, now it's ready to go to public mainnet once we achieve that reliability. And there's some other things we have to do too, like we have to complete our security audit and fix any bugs that get reported from users along the process as well. Yanin, while you're here, you want to maybe give a quick update on the status of getting to this public testnet?
Yeah, so a lot of time has been spent this past 2 weeks and this coming week in preparation for our security audit. And I think after we get through the security audit, we'll have some bandwidth freed up in order to really focus on getting an external test network deployment up. So there aren't too many updates specific to the external test network, besides the fact that the security audit preparation is taking up a good amount of our time right now. But after we get unblocked on that front, we'll be able to push a lot faster on the external test network deployment. And there should be more documentation coming soon for that as well. So it's a little easier for people to get started on the network when it's up.
Yeah, the documentation is like a big missing piece because it's possible today to deploy a test network, but you really need to give people the kind of ability to participate in it effectively with good documentation, tutorials, etc.
And with the release of the public testnet, will there be any major changes to the protocol in terms of the number of transcoders? So will the orchestrator role be introduced straight away, or is that more of a gradual?
So part of the reason why the security audit preparation stuff is blocking some of the external test network deployment tasks is because once the external test network is up, these protocol changes will be in place. So it's going to support a much larger number of orchestrators working on the network. So as has already been mentioned, we could just, all this stuff can be deployed now, but it's made a lot easier if we go through the security audit preparation stuff that might result in some changes to the contracts that we've implemented. So after we get through that, when we launch the external test network, yeah, the probabilistic micropayment stuff is going to be a part of that. So is support for a larger number of orchestrators. So is the orchestrator transcoder split. All those things should be available for use once that network is up. And as has already been mentioned, some of this stuff is missing documentation right now. So like technically it's possible, but you need some instructions and some getting started guides to make it actually usable by people that don't have the technical background just quite yet.
And like have the exact parameters, like the maximum amount of orchestrators, maximum amount of transcoders been set yet or determined yet?
We haven't picked specific values yet for that. But I think one of the things that we've talked about initially is that we're definitely going to support at least 100 or something of that magnitude. Basically, it's supposed to be a magnitude increase from V1. But in terms of an actual number, I think that's something that there needs to be more information gathering before like a decision is made, and then would like to talk to members of the community as well before a final decision is made on that front. So nothing specific there yet.
Okay, great. And one other question I had.
I have a follow-up on that. What are some of the questions and inputs needed to get to an answer on that, as well as like minimum amount of stake needed?
So for the first part of that question, some of the inputs are, well, first, this is more of like a technical input, but it's a better understanding of the gas costs associated with staking as a result of some of the changes that we've made internally to that contract. So one big change that has been made since V1 is that a big gas cost bottleneck for the network was the cost of submitting an initialized round transaction. And that bottleneck has been eliminated as a part of these changes. But in that process, some additional gas costs have been added to other staking related transactions. So we're still trying to get a better understanding of what that impact has been and getting a better understanding of how that might scale with the number of orchestrators that are on the network. So that's one input, getting a better sense of like the gas costs associated with staking transactions and the impact on them based upon these contract changes. And in terms of getting an understanding of the minimum stake, at this point, like with the network, we won't be setting an explicit minimum stake, and that's something that gets derived from the participation of the current orchestrators in the set. So the minimum stake would end up being whatever the stake of the lowest orchestrator is in that set. So can't say with any certainty what that stake would be, but that's certainly going to be impacted by the size of that set, right? Like if you have a smaller set, then you're going to have a higher barrier to entry. If you have a larger set, you might have a lower barrier to entry, but in terms of an exact number, I'm not sure that we can say what that is at this point.
Thanks.
Okay, and one other question I wanted to dive into was in regards to progress made on concurrent video stream scalability. So Yona, would you be the best one to talk about that?
I haven't been working on that too much, but Eric might have more to say on that front, or maybe Michael.
Yeah, Nelson, can you repeat the question?
So I was just hoping to run through some progress on the concurrent video stream scalability.
Mm-hmm. Yeah. So we have been testing internally about that. So until fairly recently, we have tested 100 concurrent streams on a large like on a network that's deployed on Google Cloud. And we had, we achieved over 99.99% reliability of 100 concurrent streams. We recently went up to 200 concurrent streams. We're still able to do that. But there is, like, we did discover some like resource allocation improvement opportunities that we can have. So we're still like working with that set until we solve that problem. Then we'll go to a bigger, a higher concurrent stream.
How many
or
GPUs?
a higher network.
How many GPUs were on the setup where we hit 100?
There was no GPUs, so we were using CPU based transcoding for that. Yeah, just because on the cloud, setting up GPU is kind of a pain. Instead of what we really want to do is to set up GPU mining with mining hardware instead of like a cloud, like Tesla GPU, right?
Okay, great. And is there any other changes that the community members can expect in the lead up to Streamflow?
I think that they can expect to see some nice updates on the user experience side in terms of staking on the network and being notified of the key information that they want to be notified around. I know we've kind of given some previews of wireframes for updated token holder experience and staking app in the past, and in the future we'll have the opportunity to look at kind of the new staking experience that's being built to support Streamflow. So that's one other interesting area. And I think that users on the not only protocol side, but end users on the video side who actually want to use this network for transcoding will see a world of difference in terms of, instead of just being able to use the network for kind of a single event stream or a one-off test that they're running. The network should be viable for many concurrent streams for an actual developer who wants to transcode video. And we have a product to support them in doing that hides all of the crypto blockchain side of it. And I think maybe next call or the call after that is scheduled to get a look at some of that product on the video side.
Okay, great. And did anyone else that's on the call have any questions regarding GPU transcoding or Streamflow in general?
Yeah, I've got just one question. It's about, like someone asked me recently, how much more money would people expect to be able to make by running transcoding alongside their GPU mining? So, like, this guy, his business was mining Ethereum and running a load of infrastructure, and that was his first question when I told him about live peer transcoding. Like, I don't even know how to begin to answer that. So I guess I just kind of like raise it here in case someone has some rough idea about what numbers I might be able to give back to him in dollars.
I have
I
have some preliminary benchmark numbers that might help us to estimate that in dollars. It's an indirect answer though. But this week I've been testing how many concurrent streams can I stream to a live peer transcoder node in real time, and how much kind of effect does it have on mining itself? Now, if I'm transcoding only one stream, I see less than, well, the effect fluctuates, but it ranges from something like 1.7 to 3% of an efficiency hit on mining. Now, that's while transcoding one stream with 3 renditions, and it's actually doing the full job of a single live broadcast in real time. And while doing that, it's still mining Ethereum at 98% as much as it was before, or 97%. So anyway, with that said, oh, by the way, I also tested up through 8 streams. I don't actually know what the limit is, but we saw similar effects. The more streams, obviously, the more of the hit. but it was only 8 concurrent streams only affected mining by like 11 to 12%. So anyway, scaling this back down to the 3%, imagine you're mining Ethereum, you're only making 3% less in the time that you're transcoding, but the payment for the transcode job, we're expecting that to be significantly more. Now, to figure out exactly how significantly more, I have to pass that to Doug and Eric. That I don't know. But what I do know is that it doesn't hurt the mining as much.
Okay, so that gives me some data to say you'll lose money because you won't be making as much Ethereum, which means that I need to be even tighter and sharper on the but this is how much more you will make number, which is, I guess, the bit I'm interested in as well. But thank you, Michael. That gives half the story.
To figure out how much more you'll be making, what you need to do is just ask yourself what you want to charge in order to encode that one stream of video, right? And if you're competing with a public cloud provider that's charging $3 to $7 per hour per stream of video, well, if you can provide that level of service, maybe you can charge something in that ballpark. Probably not, though. You're probably competing with kind of a do-it-yourself option, more long tail. Maybe it's 50 cents per hour, and so you have to ask yourself, what are you going to charge as a transcoder in order to disrupt that 50 cents per hour option and win business? And of course, what are the other orchestrators on the network charging, and why would broadcast nodes choose to work with you instead of work with them if they're charging less? So it's really a kind of an open marketplace determined price that can only be determined by whatever the orchestrators on the network are charging. But again, remember that the kind of cryptocurrency mining operation on one of these GPUs pays out at something like, correct me if I'm wrong, 5 or 6 cents per hour. And so if you're losing 2% of that, you're losing a fraction of a penny in an hour. But like we said, the ballparks that you could charge for the video encoding, I don't know what that will be. It'll be market determined. But if it's 10 cents an hour, 20 cents an hour, 3 cents an hour, all those numbers are way more than the fraction of a penny that you lost for the mining. And you only lose on the mining side when you have a job. Like if you don't have an encoding job, you're not losing anything on the mining side. You're not losing money.
Okay, so the low ballpark estimate was it's like 3 cents per hour. And so if it's 5 to 6 cents per hour they're making already using that GPU, then we can say to them it's like at least a 50% uplift in revenue. Is that, I mean, like, I guess it sounds like there's a lot of data and a lot of stuff still being crunched, but for me, there's we could boil it down if it's possible to boil it down to some harder, crunchier numbers to make it really simple to go and answer that in a kind of elevator pitch kind of situation, then that's something I'm really interested in finding out more about. But thank you for those answers. They kind of like give an idea. So thank you.
Yeah, and to clarify, like the 3 to 5 cent number that I threw out, that wasn't really an estimate. It was just an example because again, the question goes to the GPU miner. They get to pick how much they need to make or want to make in order to win that work. When's it worth it to them to do that? So, they're typically pretty good at squeezing that extra fraction of a penny out of each of these GPUs, and they have thousands of them potentially. And so maybe they're willing to do it. Maybe some are willing to do it for cheaper and win that work. And maybe some say, it's really only worth my time to do this if I'm going to make 10 cents an hour extra. And I believe I'll be able to win work because I'm located near the source of the demand. So it's really market determined, and we'll have to just observe how the market prices things on the network. The same way in Ethereum, we observe what gas prices people charge in order to include transactions depending on how much load there is. It's going to be a similar dynamic.
Yeah, I think when making this comparison, it's also like worth checking like our mental models that we're using to compare like the revenue that you're earning from cryptocurrency mining versus the revenue that you would earn from transcoding, just because I think it like there's two components to that revenue stream, right? So for mining, you have the block reward, and then you also have transaction fees. And for transcoding, you're going to have transcoding fees and then the inflationary reward in terms of LPT. So like I think like when you're doing the comparison, like I feel like it's always worth asking, well, are you including the block rewards and the transaction fees in this comparison? Are you just comparing the block rewards? Are you comparing block rewards versus transaction fees? Well, in that case, that's not like an apples to oranges comparison, right? So you have to compare transaction fees with transaction fees and inflationary rewards with block rewards, because the dynamics of that revenue stream are going to be different depending on what inputs you include. So like in the case of like comparing block rewards and transaction fees with cryptocurrency mining with inflationary rewards and transcoding fees on the LivePeer side of things, yeah, like you have to take into account like volatility of the token if you're also incorporating like the block reward component. And then an added input factor into that is, well, in cryptocurrency mining, the transaction fees are denominated in the same token, and in LivePeer world, you're going to be receiving two different types of tokens for the work that you're doing, and the volatility property of those tokens are going to be different. So as a result, long story short, it's a very complicated question, and I think you just have to bake in a lot of assumptions when you make that comparison.
And so just to expand on that, so for the orchestrators are taking an inflation cut, and then there's the fee portion. Are they passing both of those on to the GPU transcoders? Because does that mean that effectively one orchestrator might have an incentive to operate at a very low cost, because if they can use that to accumulate more LPT delegated to them, it might be rational to do so?
So the question is if the fee cut is passed on from the orchestrators to the transcoders. Is that the question?
Yeah, so do the transcoders also receive the daily inflation cut from the orchestrator? Or do they get to choose whether they pass that on?
So that's something that we're currently considering as like external to the core protocol itself. So the logic of how like a transcoder node gets compensated by the orchestrator is not defined within the core LivePeer protocol itself. So, but there is the possibility for like different structures, where like the simplest structure is just like a centralized payout scheme, where you have the orchestrator just, if you trust the orchestrator, then you just have them do payouts to their transcoder nodes if the transcoder nodes are operated by other people. And this ends up being a similar structure to mining pools, where like you're probably going to start off with centralized structures. Something that would be interesting is the notion of like a public transcoder pool. And if you could design like a protocol for that, where you don't necessarily need to have that centralized payout scheme, that would be interesting. But that's something that's probably going to be investigated further down the line. Although if anyone has good ideas about that, definitely more than welcome. But it's not an active priority right now.
Yeah, one of the consequences of this is like for launch of Streamflow, it's most likely the orchestrators are also running the transcoders, right? Like a transcoder is just a technical process that orchestrators are running to do the work. And if someone didn't want to run an orchestrator, they just had a piece of hardware that they wanted to run as a transcoder, they would, at the current moment, unless someone creates the right trustless public pool scheme, they would probably just need to kind of join an orchestrator pool that someone's running that has a kind of their own protocol for payments that may be centralized and trusted. Someone should run one of those pools, but again, it's outside the LivePeer protocol itself.
Okay, great. Well, look, that's all the questions I had to run through for today, unless anyone had any other questions.
Nelson, thank you again for coordinating this,
Thank
posting the
you.
call for it. It was great. We have the recording. I heard the stream never came online, so we'll have to investigate that. And I apologize for those who are watching the recording that tried to tune into the stream, but we'll get that troubleshooted for next time. We'll see everyone in 2 weeks.
Hey, Doug, it was actually fixed about 20 minutes in. Eric figured it out.
Oh.
So, yeah, FYI.
Yeah,
All
no,
right, so we got half the call on the stream. Excellent. Okay, so like I said, I think next time we're going to have a call where we dig into the kind of video product side of LivePeer. And if people have ideas or topics or questions, feel free to share them on the Discord or with Nelson, and we'll put together a good call for that in 2 weeks. Speaking of which, that reminds me, 2 weeks is during DEF CON. So maybe we'll think about the proper scheduling of that call if we need to move it around.
We should just stream the probabilistic micropayment talk as a community.
Could do that as well. Cool.
That'd be cool. Yep.
All right.
Awesome, guys.
See you later.
Thanks, Zach.
Bye.